Hi class, this is Coach Riza. In this video, we are going to talk about phase change. A phase is a homogeneous part of a system that is separated from the rest of the system by a well-defined boundary. Phase change is a transition from one phase to another, caused by the removal or addition of energy. Energy involved is usually in the form of heat. In order for phase change to happen, it needs energy. The particles of matter at a certain state needs energy to phase change. Solid to liquid, liquid to gas, gas to liquid, liquid to solid. So it's caused by the removal or addition of energy. Here are the 6 possible phase changes. We have melting, solid to liquid, sublimation, solid to gas, vaporization, liquid to gas. As you can see here, class, as the temperature rises, it means that the particles of matter from the heat gains energy. So if a solid matter acquired heat energy, the particles of that solid material or matter will eventually melt. It's due to the energy that they have acquired, and because of that energy, they can actually escape from their intermolecular forces that acting on the molecules. Same goes in the liquid state. When a liquid is heated, the particles of liquid gains energy, which causes for them to vaporize. And another is sublimation. It's the direct phase change from solid to gas. So as you can see on this part, the red arrows shows us that as the temperature goes up, the particles of matter gains energy from that heat, from the raise of temperature, and that causes for them to phase change. On the other hand, on the other side, the blue arrows shows us that the temperature here is lowered. It means that it's getting colder. Okay, so from the gas state, the gas can turn into liquid through this condensation process, wherein when it's cold, when the temperature is lowered, the particle loses its energy, and as it loses energy, it condensates into liquid, so gas to liquid. And in the liquid state, when the temperature is lowered, it means it's much colder, freezing happens. Liquid can turn into solid, so freezing or solidification. Again, it is due to the temperature. Because of the cold temperature, the particles of liquid tends to clump together. They move slower because they lose their energy, and with that, they tend to clump together until their intermolecular forces acted on them, solidifying the particles, the molecules, and phase change happens. Now, freezing happens. Same goes with gas to solid deposition. It's the direct phase change from gas to solid. It means it doesn't go to the intermediate part, sa liquid part, diretso na siya, no? Gas to solid. Deposition happens if it's cold, gas can turn into solid. For the liquid vapor phase transition, we have vaporization or evaporation. It is the process in which liquid particles with sufficient energy escape from liquid surface and enter the gas phase. So I have explained to you before class now that vaporization or evaporation happens when these particles, liquid particles, has enough energy. They can actually escape. They can actually move or phase transition to gas. Now they can actually turned into gas. Once they have enough energy, nakaka-escape sila from the liquid state. Okay? And that's how vaporization or evaporation works. No? It's a process wherein liquid particles escape into gas phase. So, of course, if there's vaporization, there is vapor pressure. So, the vapor pressure of a liquid increases with temperature. So, the more higher the temperature, the more vapor is produced. Okay, so the more liquid is being converted to vapor. So, when vapor pressure reaches the external pressure, the liquid boils. So, this is one of the properties of liquid. And they have this what we call boiling point. The boiling point, it's when the temperature at which the vapor pressure of liquid equals the atmospheric pressure. Pag nag-equal yun, class, what happens there is the vapor pressure pushes the atmospheric pressure, which gives the liquid particles to vaporize more, to easily vaporize, because they can contend the atmospheric pressure and push the atmospheric pressure. So the boiling point is reached when that happened. So the boiling temperature varies with the external pressure. Next is molar heat of vaporization. Okay, it is the amount of heat required to vaporize 1 mole of a substance at its boiling point, and is usually expressed in kilojoules per mole. So the heat of vaporization, also known as enthalpy of vaporization, is dependent on the strength of intermolecular forces. And we have here a table that shows us the different molar heats of vaporization for selected liquids. So on a specific boiling point, we have a standard value for the molar heat of vaporization. Again, take note, this standard value represents the amount of heat required to vaporize 1 mole of a substance. So for example, we have water at 100 degrees Celsius. 1 mole of water can be vaporized at 40.7 kilojoules per mole. So it means that 40.7 kilojoules is needed to vaporize 1 mole of water. For molar heat of vaporization, we have this formula. So the molar heat of vaporization is equal to the thermal heat or energy, also known as the enthalpy change, over mole of a substance. Now class, why do we have this formula? We can actually compute for the molar heat of vaporization. Now, the table that I have shown a while ago is a reference table that shows us the standard heat required to vaporize 1 mole of a certain substance. Now, it is not always 1 mole. Okay, there are samples that exceeds to 1 mole or is lesser than 1 mole of the substance given. So that is why, class, we have this formula for us to compute the molar heat of vaporization. So let's find out how we're going to apply this formula. We have this sample problem number 1 for the enthalpy of vaporization. Okay, so again, take note, class, molar heat of vaporization or enthalpy of vaporization, it's the same. Okay, so let's have sample problem number 1. To vaporize 50 grams of carbon tetrachloride, CCl4, in liquid, it requires 9.69 kilojoules at its normal boiling point of 76.7 degrees Celsius and 1 bar pressure. Calculate the molar enthalpy of vaporization of CCl4 under this condition. So the molar mass is also given. So the molar mass is 153.8 grams per mole. The given from the sample problem is the mass of the carbon tetrachloride, which is 50 grams, and the required heat or energy needed, which is 9.69 kilojoules. We are asked to find the heat of vaporization. Again, the heat of vaporization means it's the amount of energy required to vaporize 1 mole of a substance. The solution is, first we need to find the molar mass. So if it's not given, you have to find first the molar mass. But since the problem gave us the molar mass, if you look at back here, given na yung molar mass. So, nakalagay na siya dyan. It's 153.8 grams per mole. Next is to find the mole. Why do we need to find the mole? Sa 50 grams na sample na binigay sa atin ng sample problem, it doesn't mean na 1 mole ang katumbas noon. Ibig sabihin, may certain amount of mole present sa 50 grams ng sample natin. Kailangan natin siyang hanapin para malaman ano ba talaga yung enthalpy of vaporization or the heat or amount of heat required to vaporize a certain mole na amount of mole of a substance. And that's what are we going to find out here. Now, first is we need to find the mole because we need the amount of mole in order for us to compute the molar enthalpy. So, in this case, using the given mass and the molar mass, we can compute for the mole. So, 50 grams of CCl4 times for every 1 mole of CCl4, we have 153.8 grams of CCl4. So, makakancel si grams, makukuha natin si mole. And in your calculators, so dapat ang makukuha natin, it's 0.325 mole. Okay? So, ibig sabihin, class, ito yung moles na present sa 50 grams of CCl4. Okay? So, now that we have the amount of the substance, the moles, the present sa ating sample, we can now compute for the molar enthalpy. Now, given na po si energy, okay, and we also have our mole. So, just apply in the formula. We have the enthalpy of vaporization is equals to the energy over the amount or mole. So, it's 9.69 kilojoules divided by 0.325 mole. And the answer is, okay, it's 29.8 kilojoules per mole. So that is the enthalpy of vaporization for our sample problem number 1. Okay, now let's move on to sample problem number 2. You empty the contents of a 1 liter bottle of water into a pan at 100 degrees Celsius, and all water evaporates. How much thermal energy was required to evaporate this water at 100 degrees Celsius and 1 bar? The density of liquid water is 0.958 grams per ml. As you can see, class, now the given values here is that it is said that we have 1 liter of water. So, we have 1 liter of water. Pinainit daw natin sa pan at 100 degree Celsius. Okay? At hinayaan natin itong mag-evaporate. Okay? So, how much thermal energy pinapahanap sa atin? Yung energy na was required to evaporate this water at 100 degrees Celsius and 1 bar. So, pinapahanap po sa atin si thermal energy. And we were given the density of liquid, which is 0.958 grams per ml. Okay, let's see how we're going to compute this. Take note, class, we are asked to find the thermal energy. Hindi sa atin pinapaanap si enthalpy of vaporization. Yung thermal energy, ibig sabihin, class, sa formula, ito yung pinapahanap sa atin. So, how are we going to compute that? Wala tayong moles. Wala tayong heat of vaporization. Nito na ngayon, class, natin gagamitin yung standard na value. Okay, so again, meron tayong standard na molar heat of vaporization sa mga selected na liquids, in this table. So, ito nga yung pinakita ko sa inyo. So, gagamitin natin ngayon yung molar heat of vaporization na standard for water. Okay, take note, class, it's 40.7 only. Wala yung 9. It's 40.7 only. 40.7 kilojoules per mole. Ibig sabihin, sa kada isang mole, kailangan natin ng 40.7 kilojoules na energy. Now, how are we going to compute sample problem number 2? Meron tayong 1 litro ng tubig, okay, na pina-evaporate natin. Gaano kaya kalaki yung enerhiya na kailangan para ma-evaporate yung 1 litro na yon? Okay? So, let's find out paano siya na-compute. So, again, we have here the given values. We have the heat of vaporization coming from the table, 40.7 kilojoules per mole. We have the density of water, which is 0.958 grams per ml. We have the molar mass of water, which is 18.02 grams per mole. So, binigay ko na po yung molar mass. So, kung wala si molar mass, kailangan siyang hanapin. And, of course, the sample, no, the volume of the sample water, it's 1 liter. Okay? So, bakit kaya may density? Bakit kaya may molar mass? You will see here, no, why we have that values. So, we are asked to find the energy or the heat. So, first, no, we have to find the mass. Para makuha natin yung mole, diba? From our formula, kailangan natin si mole. Meron na tayong heat of vaporization. Kailangan natin mahanap si energy. Wala tayong mole. So, kailangan natin hanapin si mole through molar mass and mass. So, we're going to find mass using the volume of the water and the density of the water. So, 1 liter, convert to ml, it is 1,000 ml. Now, this ml, we need to find the mass. So, using the density is mass over volume. We're just going to use density to get the mass. So, 1,000 ml times the density, which is, for every 1 ml, there's 0.958 grams of water. And the mass of water is 958 grams. So, that is the mass of water in our 1,000 ml. Okay? So, equivalent niya yan. Now that we have our mass and also the molar mass, we can now find the mole. So, using the molar mass, we can now compute for the mole. 958 grams times for every 1 mole, there's 18.02 grams. Cancel si grams, we will get the mole. And dapat ang makukuha natin, it's 53.16 mole. Okay? So, meron na tayong mole. Meron na rin tayong standard heat of vaporization. Now, we are asked to find the energy para ma-vaporize yung 1 litro ng tubig. So, apply lang natin yung formula. Si formula will transform into this one. So, the energy or heat is equals to the heat of vaporization times mole. So, apply lang siya. 40.7 kilojoules per mole times 53.16 mole. Cancel si mole, may iwan si kilojoules. So, the energy that we need in order for us to evaporate or to vaporize 1 liter of water is, ayan, 2,163.6 kilojoules. So, ganun kalaki yung energy na kailangan para ma-convert yung 1 litro ng tubig into vapor. So, in scientific notation, you can write it as 2.16 times 10 raised to 3 kilojoules. Either of the two, it's the same. It's the correct answer. And that's how we apply the formula for molar heat of vaporization. The next phase transition is condensation. Condensation is a process when a molecule in a gas phase hits the liquid's surface. It can transfer some of its energy to the other liquid molecules or particles and remain in liquid phase. So the energy transferred out of the system upon condensation is equal to the energy transferred into the system upon vaporization. It means, class, na if we go back to vaporization, si liquid, para mag-vaporize, kailangan niya ng energy. At kung ano man yung na-acquire niya na energy, kung gaano man ito kalaki, no, in kilojoules, no, ay equivalent to sa energy na mawawala during condensation. Okay? So, si liquid, yung na-acquire niya na heat, may value siya, right? Yun nga yung na-compute natin or nako-compute natin si through molar heat of vaporization. Okay? Yung energy na nagamit para mag-vaporize yung liquid into gas, yung energy din na yun, yung dapat na mawala para ma-convert back yung gas into liquid. At yun na nga po yung tinutukoy ng definition natin here. Okay? Na yung energy ay equal, energy ng vaporization is equal dun sa energy na mawawala during condensation. So, in a negative value. Okay? Kasi kaya siya negative kasi yung mawawala sa kanya. So, the enthalpy change required to completely vaporize 1 mole of liquid water once it has reached the boiling point of 100 degrees Celsius at 1 bar. So, that's how the molar vaporization. And the enthalpy change when 1 mole of water vapor of 100 degrees Celsius condenses back to liquid water at 100 degrees Celsius. That is the molar enthalpy of condensation. Have the same values but opposite sign. So the value from the molar heat of vaporization is equal to the negative value of the molar enthalpy of condensation. So as you can see here, we have liquid to gas. It is vaporization. So yung standard for water, it's 40.7 kilojoules per mole. Now, ito rin daw po yung mawawala. Okay? Kapag si gas ay babalik ng liquid. So, kaya siya naging negative 40.7 kilojoules per mole. So, again, condensation, opposite of vaporization. Paano yun nangyayari? Condensation or liquefaction process can be achieved by either by cooling the sample and applying pressure on it. Next is the liquid-solid phase transition. Freezing or solidification. A liquid becomes a solid if heat energy is removed from it. When the temperature is lowered, the motion of the particles in the liquid slows down. The attractive forces between the particles can now overcome the motion of those particles with low kinetic energy. As a result, these particles are held together in fixed position in a lattice structure. So, as I have explained to you class a while ago, freezing or solidification happens when energy is nawala. Okay? So, nawawala yung energy kapag lumalamig. So, what happens to the particles is dahil malamig, they lose that energy, and when they lose that energy, they tend to become closer or clumped together. Because of the closeness of the particles, nabubuo nga itong forces of attraction. Attractive forces, which is the intermolecular forces, become stronger as the particles is closer. So, kaya naman nagso-solidify ang ating mga particles. Kung liquid yan, magso-solidify siya into solid. So, again, freezing is a transformation of liquid to solid. Now, yung kabaliktaran naman niya, solid to liquid phase transition, is what we call melting or fusion. So, the opposite of freezing, it is the solid to liquid phase transition. So, melting is the process when temperature of the hot solid increased. So, dahil mainit, nakaka-acquire ng energy yung solid particles. So, the vibration of the particles become more violent, and finally, at a certain temperature, the vibrations of the particles become violent that the particles in the solid have acquired sufficient kinetic energy to overcome the attractive forces between the particles. The particles then break away from one another and move away from their original position, changing phase from solid to liquid. Thus, melting or fusion happens. So, ayun na nga po, class. Dahil po sa heat energy, pagtaas ng temperatura, ang nangyayari, class, sa mga solid particles natin is that they acquire that energy. And with that, nagagawa nilang mas makagalaw, mas makamove, and with that, nakaka-escape sila sa kanilang position, sa kanilang structure. And that's how melting happens. Okay? So since they have enough energy, they are nako-convert from solid to liquid phase. So again, we call that melting or fusion. So for the solid liquid phase transition, we have this what we call molar heat of fusion. So ano kaya itong si molar heat or enthalpy of fusion? It is the amount of heat required to melt 1 mole of a solid. It is usually expressed in kilojoules per mole. So ayan, meron din po for heat of fusion. Like heat of vaporization, na meron din siya. And it means nga po, the amount of heat required to melt 1 mole of a solid. So, for heat of fusion, solid to liquid, the standard for water, it's 6.02 kilojoules per mole. Ibig sabihin nun, class, ay kaya niya, ma-melt ang isang mole ng solid water, yung H2O na solid. Ang kailangan niya na energy ay 6.02 kilojoules para ma-convert yung 1 mole into liquid, solid to liquid transition. Si heat of vaporization naman, per 1 mole, kailangan niya 40.7 kilojoules ang kanyang standard. So, of course, molar heat of fusion has its own formula. It's actually the same with heat of vaporization. Again, heat of fusion is the amount of heat required to melt 1 mole of a solid. So, heat of fusion, molar heat of fusion is equals to the thermal heat or energy over the mole of a substance. So, meron tayong enthalpies of fusion for several representative solids. So, meron naman po talagang a standard enthalpy of fusion for different compounds or different solids. For water, we have 6.02 kilojoules per mole. So, melting happens, yung solid or ice water, at 0 degrees, it will start to melt, and the enthalpy of fusion is this one. Again, take note, this is the heat needed to melt 1 mole of a substance. So, let's apply the enthalpy of fusion. So, how are we going to compute for the enthalpy of fusion? So, we have a sample problem here. So, the molar enthalpy of fusion of sodium chloride is 30.21 kilojoules per mole at its melting point. How much thermal energy will be transferred into the system when 10 grams of sodium chloride melts? Okay, in this problem class, the molar enthalpy of fusion was given. So, this is the standard value. Binigay niya yung value for the enthalpy of fusion of sodium chloride. So, tinatanong sa atin ngayon, gaano kalaking enerhiya ang kailangan natin ma-transfer para mag-melt itong 10 grams of sodium chloride. Okay, so ano yung thermal energy needed to melt 10 grams of sodium chloride? So let's see how are we going to compute for the thermal energy. Again, the formula is this one. So given si heat of fusion, pinapahanap si thermal heat. So wala tayong mole. So ibig sabihin, hahanapin natin si mole para ma-compute yung thermal energy. So we have here the given value, enthalpy of fusion of sodium chloride. The mass, it's 10 grams. Okay, so we are asked to find the thermal energy. So here is the formula. Okay, so magta-transform yan ulit. So enthalpy change or the thermal energy is equals to heat of fusion times mole. So first, we need to find the molar mass. So, para makuha natin si mole, kailangan natin si molar mass. So, using the computation for molar mass, the molar mass for sodium chloride, it's 58.443 grams per mole. So, meron na tayong molar mass, meron na tayong mass na given, we can now find for the mole. So, using the molar mass, ginamit natin siyang factor para makuha yung mole. So, we have 10 grams of sodium chloride times for every 1 mole there's 58.443 grams of sodium chloride, and the mole, so it's 0.1711 mole. Ibig sabihin ng class, ito lang yung mole na present sa 10 grams of sodium chloride. Now that we have the amount of substance, the mole, and the heat of fusion, so apply lang po yung formula. So heat of fusion times mole, cancel si mole, may iwan si kilojoules. So the answer is 5.169 kilojoules. Ito yung energy na nakailangan para ma-melt si 10 grams of sodium chloride. Okay, so that's how we use and apply the formula for molar enthalpy of fusion. Next, we have the solid to vapor phase transition. So, sublimation is a process in which the substance goes directly from the solid to the gaseous state. So, hindi na po siya dumadaan ng liquid. Diretso na siya into gas. So, solid to gas. So, we have examples here: dry ice, iodine, and mothballs. So, as you can see in the picture, kita natin yung usok. Now, for the mothballs, hindi natin nakikita yung usok, but napapansin natin yan kapag ginamit na natin yung mothballs, nilalagay natin yan sa mga cabinets, kung naobserbahan nyo lang naman, what happens there is, after a certain day, lumiliit yung mothballs. Bakit kaya ito lumiliit? Dahil po, dumadaan siya sa phase transition, sublimation process. Dumadaan siya dun sa sublimation process. Kaya po, nako-convert yung solid into gas. Yung kabaliktaran naman is deposition. So, si deposition naman, process in which the substance goes directly from gas to solid state. So, kabaliktaran naman siya ni sublimation, when the particles lose energy and changes directly into solid. So, dito naman class, si enthalpy of sublimation is equals to the negative value ng enthalpy of deposition. So, paano ba makakompute itong si enthalpy of sublimation and enthalpy of deposition? So, we have this what we call molar heat of sublimation. So, it is the amount of energy required to sublime 1 mole of solid, which is usually in kilojoules per mole. So, ibig sabihin, ito yung formula niya. Dahil direction of phase transition, solid to vapor, ang processes involved supposedly is fusion and vaporization. So, kaya naman class, ang kanyang formula, heat of sublimation is equal to the heat of fusion plus heat of vaporization. In short, hanapin natin si heat of fusion, heat of vaporization, para makompute si heat of sublimation. And since reverse ni sublimation si deposition, so kung naman yung value ni sublimation, ay for the deposition, ay magiging negative lang yung value. So that is the sublimation and deposition phase transition. The last topic that we're going to talk about is heating curve. So, the changes in the state of a matter can be represented by a heating curve, which is a plot of temperature versus time for a process when energy is added and a concentrate a specific amount of substance. Heating curve shows us the process involved step by step from solid to liquid to gas. From solid part, ice, when the temperature gets higher, nadagdagan ng temperatura, medyo umiinit, what happens there is the molecules of ice vibrates. Okay, when it reached the melting point, dito na nga po mag-i-start mag-melt yung mga molecules ng solid ice. So, may duration of time yan hanggang sa completely change na yung solid to liquid. And then, kapag tumaas pa yung temperatura, of course, as the temperature rises, the molecules of water acquires energy. When it gains more energy, it gradually, the intermolecular forces become weaker. Nagagawa na nilang maka-escape from their liquid state. Unti-unti na itong mag-vaporize. So, as it reached the boiling point, kung saan, of course, nako-convert or na-vaporize yung ating liquid into gas, no? So, the plateau here, is longer than the melting point. So, matagal po talaga, na magpakulo kaysa yung duration ng time na na-melt yung ating ice, into water. So, mas matagal yung vaporization na process, At kaya naman, kita natin here in this plateau. So, at a certain point, marireach na wherein the molecules is completely changed to vapor. And of course, yung vapor na yon in the form of steam, yun na yung H2O gas. So, dito nga, class, sa heating curve for water, this is an example of a heating curve for water. Pinapakita sa atin yung step-by-step na process, from solid to liquid to gas in terms of the temperature and the time or the duration of the phase transition.